No living animal today resembles the form of a Chalicotheres. Imagine a creature with the head of a wild horse, forelimbs elongated like those of a gorilla, thick curved claws resembling sickles, and a low hunched back reminiscent of a ground sloth. This improbable combination created a body plan with no evolutionary precedent. At the American Museum of Natural History, the mounted skeleton of Chalicotherium draws attention not for its sheer size, but for the anatomical oddity that confounds expectations. It is not a predator, it is not a plains runner, nor does it resemble any existing herbivore. This is the Chalicotheres, a creature whose posture alone raises questions about the ecosystem it once inhabited. What makes Chalicotheres especially remarkable is not only its bizarre morphology, but also the ideal conditions in which its fossils were preserved. Moist alluvial plains and humid forest floor sediments with low acidity and limited microbial decay have preserved details such as claws, shoulder joints, molars, and even scratch marks left on hard ground surfaces. According to the Senckenberg Museum, Frankfurt, many European specimens retain such fine articulation in the wrist joints that scientists have been able to reconstruct full limb motion and behavioral patterns with precision. Professor Christine Janice Brown University, a specialist in fossil ungulates, once remarked, "Chalicotheres are proof that evolution doesn't produce what makes sense, only what happens to work at the time. And sometimes what works is too specific to ever be repeated." Fossils of Chalicotheres were first described in the late 19th century from sites in Germany and France, followed by discoveries in Central Asia and the western United States. Despite their wide geographical range, they all affirm one thing: Chalicotheres had no analogues and no successors. Although Chalicotheres belong to the order Perissodactyla, the odd-toed ungulates that include horses, rhinos, and tapirs, they shared none of the survival strategies that define their modern relatives. Horses evolved to run rhinos to defend tapirs to evade. Chalicotheres evolved to stand still, extend their limbs, and pull branches down. There are no modern animals that bear resemblance, no descendants, no close relatives, no surviving genetic traces. Paleontologists at the Senckenberg Research Institute have referred to Chalicotheres as an evolutionary ghost branch, a solitary offshoot on the tree of life that never expanded and was never repeated. Some extinct relatives, such as Moropus elatus North America or Chalicotherium goldfussi Europe, have been described as gorilla-hoofed browsers, leaf-eating animals with primate-like arms and hoofed feet. Their low, flattened molars indicate a diet of soft, fibrous plants, while their large, thick claws were often misclassified as carnivorous adaptations in early fossil interpretations. Compared to modern folivores like African elephants or giraffes, Chalicotheres chose a completely different evolutionary path, using arms instead of necks, shoulder flexibility instead of height, transforming their forelimbs into mechanical tools to manipulate mid-level vegetation zones that few other animals could reach. Chalicotheres were neither apex predators nor fast-moving specialists, and certainly not carnivores. Their ecological role was uniquely tied to the mid-canopy level of ancient forests, zones too high for most ground-dwelling herbivores to access, yet too low for tall browsers like giraffes. With elongated forelimbs, highly flexible shoulder joints, and crescent-shaped claws, Chalicotheres functioned as biological cranes, pulling down branches to feed on leaves, flowers, fruits, and tender shoots. According to a study by researchers at the Field Museum, Chicago, the enamel pattern and wear marks on fossilized teeth of Anisodon grande suggest a diet dominated by soft cellulose-rich and occasionally thorny woody plants, reinforcing that browsing from elevated vegetation layers was not a preference, but a necessity. The use of forelimbs for food manipulation rather than locomotion is an evolutionary rarity among ungulates. Where elephants use trunks and primates use hands, Chalicotheres combined mechanical traits from both groups in a wholly unique morphology. They did not climb, fly, or dig. Instead, they walked and reached slowly but precisely. Within their ecosystems, Chalicotheres may have played key roles in mid-canopy pruning seed dispersal via feces and niche regulation, similar to modern forest elephants. Unlike elephants, however, they lacked any substantial defensive features beyond sheer size. Their survival hinged almost entirely on the long-term stability of their forested environments. A close look at the mounted skeleton of Chalicotherium at the Natural History Museum in London reveals striking asymmetry between its fore and hindquarters, a high shoulder ridge, sloped back disproportionately long forearms, bent like those of a gorilla, and short, stout hind limbs. Its locomotion was defined by flexed wrist walking unguligrade flexed posture, a slow but stable gait resembling that of extinct ground sloths. Research from the museum's paleontology team indicates that Chalicotheres' forelimbs had spherical shoulder joints, a rare feature among ungulates, granting it wide multi-axial movement. This anatomical trait explains how it could pull down vegetation instead of relying on mobility like other herbivores. Where traces on the inner surface of claws further suggest habitual knuckle walking or possible light-scratching behavior, potentially for mineral gathering or territory marking. Its molars were broad, flat-surfaced and thickly enameled, optimized for grinding fibrous plant matter. A morphological report by the Senckenberg Research Institute Frankfurt highlights the remarkable development of the masseter and temporalis jaw muscles, comparable in strength to modern folivores, like howler monkeys and lemurs, enabling powerful chewing cycles for leaf digestion. Dr. Mikael Fortelius, University of Helsinki, proposed that some Chalicotheres could rear onto their hind legs for short periods, similar to North American black bears when foraging, allowing them to reach higher branches. However, with adult individuals weighing over 200 pounds, this posture was likely used sparingly, not as a means of locomotion. The combination of unusual posture, primate-like forelimbs, and highly specialized dentition positions, the Chalicothere as a creature seemingly designed for a very specific ecological niche. It competed neither through speed nor armament, but through exclusive access to resources unreachable by others. Though its physical form may evoke a predatory beast, the Chalicothere was firmly rooted in the order Perissodactyla, the odd-toed ungulates alongside horses, Equidae rhinos, Rhinocerotidae, and tapirs, Tapiridae. However, Chalicotheres diverged into the suborder Chalicothereoidea nearly 50 million years ago. Phylogenetic analyses by Colbert and Schoch, American Museum of Natural History, 1993, confirm that Chalicotheres have no living descendants. All related species within this clade went extinct by the late Pleistocene, largely due to climatic shifts and the decline of humid forest ecosystems. No genetic traces of Chalicotheres-specific traits are present in any extant species. Compared to horses, Chalicotheres were slow and lacked agility. Compared to tapirs, they were larger but poorly adapted to aquatic habitats. When placed beside rhinos, they had no horns or protective skin armor. Chalicotheres represent a unique evolutionary gamble, an unshared strategy that was neither continued nor replicated. They are a genuine branch of paleobiological history, standing alone in both form and function. Today, Chalicotheres do not only exist in fossils, but also in museums, scientific literature, and even in the realm of popular imagination. Reconstructed models have appeared in major exhibitions, such as those at the American Museum of Natural History, New York, the Senckenberg Museum, Frankfurt, and the Royal Belgian Institute of Natural Sciences. In paleontology education, the Chalicothere serves as an ideal example for teaching about biological diversification and specialization. Professor Thomas Holtz, University of Maryland, once described it as the antithesis of modern Darwinism, a creature that succeeded in its specific ecological moment, but failed to adapt for the long haul. It was never meant to be an ancestor, but rather a perfectly optimized temporary form. Although it never reached the fame of dinosaurs or mammoths, the Chalicotheres continues to leave a quiet imprint on popular culture, largely due to its unforgettable form. Creature designers and screenwriters have frequently drawn inspiration from its horse-head primate arms clawed hand motif as a template for imaginative species. In the Pixar film The Good Dinosaur, 2015, observant viewers speculated that the design of the serrated-toothed dinosaurs and certain forest creatures may have been loosely inspired by ungulate fossils such as Chalicotheres, though they are not explicitly named. In the gaming world, Capcom's Monster Hunter series introduced beasts like Rajang and Kongalala, with long arms, hunched posture, and clawed forelimbs that clearly echo the flexed wrist gait of Chalicotheres. In the world of paleo-art, Chalicotheres are often rendered in mysterious, near-mythical environments, portrayed as ancient guardians of primeval forests. Paleo-artists like Mark Witten and Mauricio Anton have recreated Chalicotheres with a mythologized presence, not because of their power, but because of their uniqueness. In a world where imagination plays an increasingly important role, Chalicotheres have become more than fossil relics. They are symbols of how boldly nature once experimented with life forms unlike any other. Chalicotheres are proof that even extinct species can continue to live on, through science, through creativity, and through the questions humanity has yet to answer. The last known Chalicothere fossils were found in Asia and East Africa, dating to the late Pliocene, roughly 3 million years ago. According to research by Lucas et al., New Mexico Museum of Natural History, 2011, their decline coincided with a global ecological shift from humid forests to dry grasslands, and from tall mid-canopy trees to lower, less accessible vegetation. With their upright stance and a feeding strategy reliant on intermediate canopy levels, Chalicotheres lacked the tools to adapt to this new ecological context. They had no high-crowned teeth like horses, hypsodonti, no specialized digestive systems for dry grasses like bovids, and no mobility to compete across vast plains. Their slow gait and dependence on low-hanging foliage gradually shrank their viable habitat. Unlike species that were hunted to extinction or destroyed in geological disasters, Chalicotheres had no dramatic end. They simply faded from the stratigraphic record, vanishing silently from ecosystems, much like how they once lived. In a natural world driven by constant movement, where species evolve for speed, strength, or social cohesion, Chalicotheres chose a solitary path, a life optimized for ecological stability and mid-canopy specialization. But it was precisely this specialization that made them vulnerable when the forests disappeared. So too did their way of life. No modern species has replaced the ecological role once held by Chalicotheres, nor has any animal replicated their living strategy. Not fast, not agile, not social. Chalicotheres simply stood still, stretched out their long arms, and drew the forest canopy to themselves. Today, their skeletons do not lie scattered in desert sands like forgotten memories. They stand visibly and solemnly in the halls of major museums: the American Museum of Natural History in New York, the Natural History Museum in London, and the Senckenberg Museum in Frankfurt. These are not just paleontological artifacts, they are physical testimonies to a life form that had no precedent and will likely never recur. Chalicotheres did not succeed in evolutionary longevity, but their value lies not in permanence, but in the fact that they once represented a path nature dared to explore, bold, refined, and irreplaceable. Though extinct, they remain on display as an opening chapter that never received a conclusion, a reminder that sometimes the most precious evolutionary attempts are those that were never repeated. In a world shaped by survival through competition, where species adapt, dominate, or disappear, the Chalicotheres chose a quieter existence, one built on ecological consistency and extreme specialization. And it was precisely that which made it fragile. As the middle canopy vanished, so did the creature that depended on it. Today, reconstructed skeletons of Chalicotheres rest in the museums of New York, London, and Frankfurt, not just as fossils, but as the embodiment of a fundamental question: how many life forms throughout evolutionary history experimented with strategies so strange they could never be passed on? The legacy of the Chalicothere is not one of triumph or duration, but of having once existed as a structure no one saw coming, an evolutionary chapter that was neither flawed nor repeated, a creature that stands outside classification and may forever remain a draft never fully written.